So today we shall be studying about quadrature, that is the area of the parametric curves. In the last class we have seen how to calculate this area for Cartesian curve. In this lecture we will be talking about parametric curves. So for that, let us suppose the given parametric curves have the equation of this form: x is equal to f of t and y is equal to g of t. So then, how can we find the area which is bounded by this curve x is equal to f of t and y is equal to g of t? These two curves and the x-axis having coordinates from alpha to beta. So what we are saying if you have some curves, so what would be this area between x-axis and the curves and between the points alpha and beta, right? So this area in Cartesian coordinates, it was given by integration y dx, where x is a and y is b, and whenever your x is a, the value of t is alpha. So because we are talking about parametric curves, our x is a function of the variable t, then y is also the function of variable t. Earlier we only had these two parameters or these two variables. So this y was the dependent variable, x was the independent variable, but in this case both of them, they are the dependent variables, whereas the variable t, that is the independent variable, right? So we are now seeking to find this area in terms of the limits of t. So that means what we'll be doing, we shall take, instead of this dx, we will now take dx by dt, and then the integration would be performed with respect to t. So the limits would then be t varies from alpha to beta. So this would be the area. And what is y is given to be g of t, so this is g of t. And what is dx by dt? That is given to be the derivative of this curve, so it would be f dash t. So this is the formula that we shall use to calculate the area for the given parametric curves. So let us see one example. The example says, find the area of the curve x is equal to a cos cube t, y is equal to b sin cube t. So we have already seen what these curves look like. They are nothing but asteroid, and their figure or the curve look like this. This point is a comma 0 and this point is 0 comma a. Here t is 0 and here t is pi by 2. So that is the angle. So this t represents the angle here in this case, and we know this axis gives you the angle 0 and this axis give you the angle pi by 2. So what would be this total area? So this total area, you can see, due to symmetry, we can only calculate the area of this much portion, the green shaded region, and we can multiply that by 4. So that will give you the complete area for this particular curve. So area would be 4 times the area of this particular region, and for this particular region you have y, you have dx by dt, and you have you will perform its integration from dt, where the limits of t, that will vary from this point to this point. So here the value of t is pi by 2 and here the value of t is 0. So that means we would have the area as the value of y, which is b sin cube t, so this is b sin cube t, and the derivative of x. So x is given to be a cos cube t. So we have dx by dt, that would be equal to a. The derivative of cos cube t would be 3 cos square t, and then the derivative of cos t would be minus sin t. So this is the derivative of x and dt. So we have to simplify this and we have to perform the integration. So this is the task, and remember that the limits here are not from 0 to pi by 2, but they are from pi by 2 to 0, because we are moving from this point to this point in the first quadrant. So we can simplify this 3a and b, they are constant, so I can take them out from this integration sign. 3ab into 4, they become 12ab, right? And we are only left with sine t raised to power 4 and cos t raised to power 2. Moreover, this negative sign, that is used to invert these limits. So we can write the limits now from 0 to pi by 2, and the negative sign is absorbed in inverting these limits. So we have to calculate the integration for this function. Now this is not so direct. We do not have direct formulas to calculate integration for this terms. So what we can do, we can use the value of cos square t as 1 minus sine square t using this relation, and we can substitute it here. So we would have sine raised to power 4t and sine raised to power 6t. Then we can write this as sine square t whole square. So yes,
मैम ये कैसे हुआ?
So next, in order to solve this sine power 4t, what we will do, we can write this as sine square t raised to power 2, and we can write this as sine square t raised to power 3. No problem in doing this. So now we can use this formula of sine square t. What is sine square t in double angles? It is 1 minus cos 2t divided by 2. So I am just substituted these values here. Then I can open up this square and this cube values. So when you open up the square, you have these quantities, and using this formula, right, this you all might know, and when you open up this cube, you will have this quantity. So this is obtained using this particular formula. So next is, I have again substituted this quantity, because you cannot perform this integration cos square 2t. So here, instead of this cos square 2t, I have substituted 1 plus cos 4t divided by 2, the double angle formula. And here, instead of this cube term, because you cannot perform the integration of cos cube 2t, so here I have used this formula cos 3t. So the triple angle formula for cos. So from here I have calculated the value of this one in terms of this and this. So it would now become cos 6t, because the angle here is 2t. So it would be, if the angle is t, it is 3t and t. If the angle here is 2t, it would be 6t and 2t, right? So substituting this value here and this value here, I have these expressions. Moreover, when you simplify this, you again have this cos square 2t. So cos square 2t term, again I can use this formula of double angle. So it would be 1 plus cos 4t divided by 2. So this is the simple trigonometric calculations that you already know how to perform. So I can collect all the constants here, open up the brackets. So when you simplify this, you will have this value. Then you can take the cos 2t terms, and then this would be this one, and then cos 4t would be this one and this one. So it is here, and then cos 6t. So this is only one term, so it is present over here. So these are the terms. You can collect all the like terms and then add up all the coefficients. So finally you have terms like this. So now you are able to perform its integration. So what would be the integration? So the integration of this term is simply, this is constant, so its integration is t. Then we have the integration of cos 2t as sin 2t by 2. Integration of cos 4t is sin 4t by 4, and integration of cos 6t, that is sin 6t divided by 6. And we have limits from 0 to pi by 2. So when you substitute the limit, upper limit pi by 2, what you will have, 12ab as such, value of t as pi by 2. Then when you substitute pi by 2 here in this expression, so you would have sine of 2 into pi by 2. So this would be sine pi, and you know what is sine pi? Sine pi is equal to 0. So this term would be 0. Next, when you substitute pi by 2 here, so you would have sine 4 into pi by 2. So this would be sine 2 pi. So sine 2 pi, that is again equal to 0. So this term is also 0. When you substitute pi by 2 here, you would have sine 3 pi. So this is also 0. So all these terms are 0 when you substitute pi by 2, and when you substitute 0 here, this term would be 0. Sine of 0 is 0 in all these cases, so we are only left with this term. So when you simplify this, your final area that comes out to be 3 by 8 pi AB. So this is the final answer. So if there is any problem in this one, you can ask. So next is to find the area when the given curves are x is equal to f of t, y is equal to g of t, and now we will calculate the area of the given curve with x-axis, where the points on x-axis they are defined by t is equal to alpha and t is equal to beta. So we would have something like this. So this would be the given curve and this would be the y-axis, and we are to calculate the area from say alpha to beta. So this would be the area in this case. This is the y-axis. So here the area is calculated by inverting the roles of x and y. So here we have integration, t varies from alpha to beta, x of dy by dt into dt. So what is x? X is simply f of t, this is given to us, and what is y? Y is given to be g of t. So when you take its derivative with respect to t, it would be g dash t dt. So this is the formula for calculating the area. So let us see the question. The question says, find the area which is included between one arc of cycloid. So now we have drawn this curve cycloid, if you remember. This x is equal to a sine theta, a theta plus sine theta, and y is equal to a 1 minus cos theta. What is the cycloid? Cycloid is something like this. The one I have just drawn here. The curve is like this. How this curve is obtained? This curve is obtained when you fix one point on the tire of one cycle, right? So say this is one cycle, right? This is one cycle. So when you fix some point here, and when the cycle starts moving, so your point would go something like this. If you're tracing the curve followed by this point when this cycle moves in this forward direction, so whatever is this point, this is also one point, the point could also be like this. So this is the given curve that is known as cycloid. So here with this given equations, x is equal to a theta plus sine theta and y is equal to a 1 minus cos theta, the curve would something be like this, and they are saying calculate the area between only one arc of the cycloid. So we are to calculate this area for this one cycle. So it would be the theta here varies from, this point is 0, this point would be theta is equal to pi, and this point would be theta is equal to minus pi. So this is one another story. How would you trace this curve? So tracing of using the technique to trace polar curves, you can trace this curve, and once you have this curve you can find out its area. So what would be the area? This is the shaded portion that we are interested to calculate. So here you can see this is symmetrical about this y-axis, so our area would simply be twice of that in the first quadrant, right? This area, so it would be 2 times integration of x dy by dt. So this formula we'll be using here. So x into dy by dt into dt. So according to this formula, your angle theta varies from, theta is 0 here. So theta varies from 0 to theta is equal to pi. So our angle is this one. The value of x is given to be a theta plus sine theta. So this is the value of x. And what is the value of y? Y is given to be this. So its derivative with the respect to theta, it would be a, because it is constant, it is as such. Derivative of 1 is 0. Derivative of minus cos theta is sine theta. So this is the derivative. So we can substitute these values and we can now perform this integration. So firstly we'll multiply the terms, a into a, that would be 2a square, 2 is present over here, and theta into sine theta, first term, then sine theta into sine theta, that is second term, sine square theta. So now we can perform this integration. For integration of this term, we would have to apply by parts. So first function and second function. Integration of this term would be first function as such, integration of second, minus integration derivative of first term, that is 1, into integration of second, that is cos theta d theta. And the integration, for the integration of the second term, we'll again use the double angle formula. So it is equal to 1 minus cos 2 theta divided by 2. So this is the formula. So the final answer here is 3 pi a square. This is the area between one arc of the given cycloid. So I have this one question for you. Please note it down. The question says you have to prove that the area which is bounded by this hyperbola. What is the shape of hyperbola? Hyperbola looks like this, right? So they are saying prove that the area bounded by the hyperbola and the axis and the ordinate from the point A cos hyperbolic theta and B sin hyperbolic theta is this one. So this is the given area. That what is this sin hyperbolic theta? Sin hyperbolic theta is e to the power theta minus e to the power minus theta divided by 2. And what is cos hyperbolic theta? This h represents for hyperbolic. So this cos hyperbolic theta, that is equal to e to the power theta plus e to the power minus theta divided by 2. So when you take the derivative of this sin hyperbolic theta, you can take the derivative of this term and you will be seeing that its derivative is simply cos hyperbolic theta, and the derivative of cos hyperbolic theta, that is equivalent to sin hyperbolic theta. It is plus here, unlike the simple functions. What is the derivative of cos theta? Simply it is minus sin theta, right? So here we have plus. Moreover, the integration of this sin hyperbolic theta d theta, that is equal to cos hyperbolic theta, and the integration of this cos hyperbolic theta d theta, that is equal to sin hyperbolic theta. So here all the terms are positive. So that is one difference between these normal cos theta sin thetas and the hyperbolic sin thetas and cos thetas. So here in this question we should use this one. If you are not comfortable, we have several different formulas for this hyperbolic functions. If you are not comfortable with solving how to solve this how to perform calculations with this sin hyperbolic functions, you could in the very starting of the question substitute these quantities, work out the calculation with e to the power thetas and minus thetas, whatever is the answer, finally substitute back the quantities sin hyperbolic theta and cos hyperbolic theta.